Okay, this will be our final go-around for roots and radicals. First off, I don't want that third power here, okay? We need to approximate what the fourth root of 5 is. Well, it's a fourth root, it's even, so we will put the plus minus, and then I'm going to take 5 to the 1/4 power to figure out what that is, 1.49 or 50, okay? I don't really care which one you put. You can put 50, you can put 0.49, either one's okay. Okay, multiplying roots. Okay, there are 3 steps to do this. I'll put it over here so we have some room. So first I multiply the outsides, and that's 6, and then I multiply the 2 fourth roots together, so 162 times 3. I got 486. Then, step 2, I drop my 6, and then I'm going to write this as a product of 2 fourth roots. And I need to have this one be an actual fourth root that has an equal. So you look up, eventually you see 81 on your list. You're under fourth roots, perfect force, okay? So 81 and 6. And this is not 9 because it's a fourth root. So it's actually 3. Now I take the 3 times 6, I get 18, and then root 4 over 6. Okay, my next problem is addition, okay? So I write out, make my chart, and I've got 3, root 3 over 135, and then I've got 2 with a cubed root of 40, okay? So first, I look up 135 under perfect cubes. It's not on the list, but I need to see what it divides by from that list, and it's divisible by 27. Okay, you got to do trial and error. So I drop the 3, I make 2 cubed roots, and I divided it by 27, and I end up getting 5. So the cubed root of 27 has an equal, and it's equals 3. Now don't add these, you times these, okay? That's 9 with a cubed root of 5. Now the other one, 40. It's not a perfect cube, but it does divide by 8, okay? So I drop the outside 2, and then I make 2 cubed roots, and I know if I divide that by 8, I get 5. So the cubed root of 8 has an equal, and it's 2. So I take 2 times 2, that's 4, with a cubed root of 5. Okay, now that they're like terms, we got a cubed root of 5, and then I add the outsides. 9 plus 4 is 13. Okay, now when I got variables in here, again, I want to break this up. Square root of 108, square root of x to the 7th, square root of y to the 5th, and the square root of z to the 8th. Okay, so I break this up. It's not a perfect square, but it does divide by 36, okay? So 108 divided by 36 is 3. This has an equal, and it would be 6. So I have 6 with the square root of 3. Okay, now you can do your groups of 2. Again, let me explain how this works. X to the 7th means x times x times x times x times x times x times x. Now, if it's a square root, I would think of it being 2 at a time, okay? So how many full, and then this one would just get its own. So how many full roots was I able to make? I was able to make 3. So x to the 3rd comes out here. And then this x here is still in the root. I can get 3 groups with 1 left over. Okay, if I've got 5 y's, I can get 2 full roots with 1 left over. 8, I can get 4 full roots, and there would not be any left over. Okay, so I put a 6 outside, a 3 inside. I put an x to the 3rd outside and an x inside. I put y to the 2nd outside with a y inside, and then I put z to the 4th outside. And I'm going to put a little 2 here to tell myself, my audience, that's a square root. Okay. All right, that's all you need the root sheet for. Now we're going to solve some equations. Okay, solve the equation. So first off, I have a root. Now make sure the outside of the root is clear. It is. There's nothing here, and there's no plus or minus outside of the root. So I can right away go to my second power. Okay, that cancels, and that becomes 2x plus 1. Now again, 2 is just a simple power, so don't put plus minus. It's 49, and then I can get my one answer by subtracting 1. So 2 times x equals 48, and then I divide by 2, and I get 24. Okay, my next problem, I have a root, but it's not clear outside. I want to do the second power, but first I got to get rid of the plus 6 first, and then we're going to divide by negative 2. So I need to minus 6. So now I have negative 22 over there, and I've got negative 2 times the square root of x minus 3. Okay, we're still not clear because we have this multiplier of negative 2. So I need to divide by negative 2. Remember, don't add or subtract that. That's a multiplier. You divide. So it's 11 and the square root of x minus 3. So now that my square root's clear, I can go to my second power. So that cancels, and we have x minus 3. And on the other side, 11 times 11 is 121. So I add 3, and x has an answer of 124. Okay, the problems that start with a root, I don't want to see plus minus on any of those, okay, because I never actually, the root's there and I'm getting rid of it, okay, I don't bring my own root in there. Okay, the next one, now this time we don't have a root, we also don't have a parentheses, so we're not going to use q. I just need to clear that x to the 4th so I can do a fourth root, so I need to divide by 3, and x to the 4th is equal to 100. And then it's time to do a fourth root, like I said I was going to. Now, when I take the even root of a number, I need the plus or minus, okay? And to figure out what that is, I take 100 and raise it to the 1/4 power on my calculator, and that's 3.16. Okay, so that has two answers, positive 3.16 and negative 3.16. Okay, parentheses x plus 2 to the 4th power minus 1 equals 80. So I don't have a root here, so I'm not going to do a second power, but I do have a parentheses, and everything in that parentheses belongs to the 4th power. So I would be smart to use the q and then the table. So we don't have a number in front. The q is going to be to the 4th power, minus 1 equals 80. So I need to clear, I want to do a fourth root, but first I need to clear the q to the 4th. So I plus 1, so q to the 4th power equals 81. Now that my q to the 4th is clear, I make a fourth root. And when I take the even root out of a number, the plus or minus is needed. So I take 81 to the 1/4 power, and I got 3. Now I need to do both sides of my chart because it is plus or minus because it's an even root. So 3 and negative 3. And then I bring in my x plus 2. So I'm minus 2, so x is going to equal 1 there. Minus 2, x is negative 5 there. Okay, so that's two answers. Remember, if it would have been an odd power, I would have just done one side because I would have used an odd root. Okay, next one, 7x to the 4/3 power, that's a 3 there, equals 175. So we don't have a root. We also don't have a parentheses. I just need to isolate the q to the 4/3 power. So first I need to divide by 7. And I have x to the 4/3 power. 175 divided by 7 is 25. And then it's a 4/3 power, so what I do is reciprocate it. So 4 over 3, that cancels, and 4 over 3. Now when I do reciprocals, I need to know that the 4 is a power and the 3 is a root, okay? So the root number is odd, so I don't need the plus minus. I just take 25 to the power of 4 over 3, and I get 73.1, okay? Kind of an odd-looking answer, but that's right. Okay, and then number 10, I have a root, so I'm going to use a second power, but first, is my root clear outside? Yeah, so I can go second power. Now this side we have 9x. Don't forget about the 9x. Now to find what x minus 2 to the second is, I need to duplicate that. I'm going to make the 10 plus negative, and they both have to be the same. We don't switch the sign. And then I do my FOIL method. So I take x times x. I take x times negative 10. I take negative 10 times x. And I take negative 10 times negative 10. So that gives me x to the second. A 1x to the second gives me a negative 10x, a negative 10x, and a positive 100. Now, we got to go over here because we have 1x to the second. Negative 10 plus negative 10 is negative 20x. And then I have my 100. Now, I have x to the second and x, so all my x's are not like terms, so we need to move everything to one side so we can factor. So I move the 9x out of here under the negative 20x, so I have 1x squared minus 29x plus 100 equals 0. And now I factor the trinomial, GCF, and then we're going to go to the t-chart. There is no GCF, okay, ABC. So I take A times C, it's positive 100. So I'm looking for a sum that equals 29. And that is going to be 4 times 25. And A is equal to 1, so I just need 2 parentheses. I go XX, 4 and 25. Now I have minus 29, so you're going to have minus 25, and sum would mean they're the same. They have to match on a sum, so minus. So x minus 4 could equal 0, or x minus 25 could equal 0. So I add 4, and I get 4. I add 25, and I get 25. 4 and 25. Okay, rationalize the expression by multiplying. So it says 4 plus the square root of 3. Now, all these problems need one number in the end as the answer. Okay? So I see a plus, so I'm going to have to switch mine to minus, and I put the same thing, because the middles will cancel. Now, it's smart to put 1s in front of your square roots, and then I multiply away. I take 4 times 4. I take 4 times negative 1 with a square root of 3. I take 1 square root of 3 times 4, and then I take 1 square root of 3 times a negative 1 square root of 3. So that equals 16. That's going to be negative 4 with a square root of 3. That's going to be positive 4 with a square root of 3, so we cancel those because they make 0. That's going to be negative 1, because 1 times negative 1. And then that's going to be a square root of 9. And the square root of 9 has an equal, and it's 3. So 3 times negative 1 is negative 3. So I can add those last two. 16 plus negative 3 is 13. Okay, the one next to it, there is no plus, there is no minus. So I don't need to FOIL. I just times by the square root that's here. Okay? And that's going to be 4 with the square root of 9. But we know the square root of 9 has an equal, and that's 3. 3 times 4 is 12. Okay, i's work the same way. Okay, I have a plus, so I'm going to switch mine to minus. 5 minus 2i, and then I do my FOIL. I got to take 5 times 5. I've got to take 5 times negative 2i. I take 2i times 5, and I take 2i times negative 2i. So that's 25, negative 10i, positive 10i. We can cancel those. And that's negative 4 with an I to the second. But I to the second has an equal, and that equal is negative 1. So negative 1 times negative 4 is 4. So 25 and 4 makes 29. Okay, then 7i. There is no plus, there is no minus. So like here there was no plus minus, I multiplied by the square root I had there. Here, if there's no plus minus, I just multiply by the letter that's there. So 7i times I, it's 7, and then the I goes to second. But I to the second has an equal, and that's negative 1. Negative 1 times 7 is negative 7. All these, I just end up with one value at the end of the problem. Okay, then graphing square roots. Graph y equals -2 times the square root of x plus 3, and then plus 8. Okay, so now with that being established, let's get the square root so there's only the variable x inside of it. And I will go back and minus 3 at the end. Okay, so if x is a square root, we're only going to pick perfect squares. So 9, 4, 1, 0, and negatives are not perfect squares, so we have to stop. Okay, so I insert negative 2, square root, and I put 9 in there. Close the parentheses before you hit plus 8, because you don't want the 8 in the square root, so that's 2. I plug 4 in, -2, square root 4, close it, and then plus 8. You got to close the parentheses. That's 4. 6 and 8. Now it's time to go back and do the opposite of plus 3 to all your x's, which is minus 3 to all of them. So that's 6, 1, -2, -3. Okay, so -3, 8 is my last point. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And that's your stop point. You can't go to the left of that. -2, 6. 1, 2, 1, 2, 3, 4, 5, 6. 1, 4. 1, 2, 3, 4. And then 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. Okay, that is my stop, so don't go past that. But you need to put an arrow on this side because you can keep going that way. That'll just give you more positives to put in the square root.